Hi, I'm Raul Angulo. I'm the author of the 4th edition, Engine Company Fireground Operations, published by the NFPA in conjunction with Jones Bartlett Learning. And so this is the latest Engine Company textbook on the market right now. Very comprehensive. And I'm going to talk about Chapter 2 today. Chapter 2 is on fire dynamics. Fire dynamics is the term that encompasses fire chemistry, fire behavior, all the properties and physics that go into the combustion process. The fire triangle, the fire tetrahedron. So again, I ask you the question, ultimately who bears the cost of your training? And I'm saying it's you. You need to invest ultimately in your training. So we hear on the national stage that we have to return to the basics. When accidents happen, it's because we forgot the basics. And they're talking about the basics of hose evolutions, ladder evolutions, things like that when you hear the basics. So when you hear the basics, what do you think about? What are the basics? I'm taking it a step further. Again, the whole purpose for this textbook, one of the mission statements for me, in addition to implementing the UL-NIST studies, is I want to save firefighter lives. If we haven't seen a significant drop in the line of duty deaths in relation to the civilians that are actually being saved when those firefighter lives are lost, then we have to question the curriculum on how we're teaching firefighting. So to me, the basics starts all the way back to fire chemistry. Every fire, every event that involves combustion and fires inside of buildings ultimately breaks down into chemistry and physics and gravity. Those are like the three major forces. So when you go back to the basics, I'm saying we need to go back to understanding the chemistry of fire. If my career is a cross-section of how it is across the United States, really the only fire dynamic training that I got was in drill school when I first came into the fire department. Maybe you had a day of fire chemistry, if that. The requirement for firefighter training doesn't spend a whole lot of time on the chemistry. So Chapter 2 does that. Chapter 2 is called Fire Dynamics. I go through the introduction. Of course, we talk about the fire triangle and the fire tetrahedron. We talk about the chemistry of physics and matter being broken down from solid, liquid into gas. We talk down to the molecular level and talk about endothermic and exothermic reactions. These are forces that happen throughout a fire. We talk the basics, the sources of heat, chemical, mechanical, electrical, static electricity, solar energy, even nuclear. Nuclear energy is something we don't really understand that well in the fire service, but it's definitely going to come more and more into play in the future, I believe. We talk about the difference of vapor pressure and vapor density. Why is that important? Because some gases are heavier than others. One of the times that became really significant to me was one of the first times I was given a multi-gas detector to check the levels of gas on a hazardous materials leak that we responded to. And the reality was I didn't really know what I was doing. I mean, we had simulated using the gas detector in drills, but since you don't drill with real chemicals, it's hard to do a realistic drill using the gas detector. But it's important to understand, for example, like natural gas and propane, two of the major gases that we use to heat our homes and cook our foods, is that natural gas is lighter than air and goes up, and propane is denser and it will tend to sink to low spots. So if you don't understand that, when you go take readings with a multi-gas detector on propane, you better have that wand starting at the bottom, because that's where that gas is going to accumulate. A lot of times it's assumed that the firefighter knows that, but they don't. We discussed the traditional fire curve and the differences of how those curves have been bent with the UL-NIST research. So just looking at how to read the graphs, we're including some photos in there on how they were able to explain the fire growth of ventilation limited fires, the new explosive growth stage that we've included in here, the fully developed stage, the decay stage. Why is decay stage so important to understand? Because that's typically the side of the fire curve where we're going to encounter smoke explosions, which are different than backdraft explosions and flashovers. So that's discussed in Chapter 2. We talk about modes of heat transfer, making sure that everybody understands that heat always transfers from a hotter object to cooler objects, similar to path of least resistance with pressurized gases. We talked about the effects of heat with steel, convection, conduction, radiation, and then we get into the flow paths. This is one of the first chapters that starts defining and showing pictures on how you can understand the different types of flow path. There's bidirectional flow paths and unidirectional flow paths. These are terms that I had to learn late in my career, so I never knew what it was. I mean, we knew that they were like fire tunnels, and we understand that the currents of air flow a certain way, but understanding the definition of flow paths is really critical to pursuing firefighting from here on forward. So you'll become very, very good with understanding the different types of flow paths. We talk about radiation, like I said, the physical state of fuels and its effects on combustion, solids, how they're stacked horizontally, vertically, how that affects fire growth. We define pyrolysis fairly extensively. We talk about the orientation of fuels. We go into liquids and gases. We talk a little bit about smoke and the byproduct of combustion, which is smoke. And we talk about all the chemicals that are in smoke, because smoke is now considered fuel and carcinogenic byproduct of combustion. Talk about the theory of extinguishment and how that comes into play on a bigger level. Obviously, we extinguish fires by breaking one leg of the fire triangle, right? So water obviously cools the heat below its ignition temperature, but we can also break the fire triangle by controlling the flow path or removing the air leg of the fire triangle. So we'll go through that. We're going to talk about fire behavior events. In there we talk about thermal layering. We're going to define rollover, flashover, backdraft, and smoke explosions. So these are terms that are all extreme fire events, and we take time to define those on a molecular level so that you understand what's happening. We talk about rapid fire growth and what constitutes that. We're going to talk about the behavior of ventilation limited fires. And then finally, wind-driven fires. There's a really cool table here with all the hostile fire events. I have it laid out by the event. For example, flashover, explosive fire growth, backdraft, smoke explosions, and flameover. And in another column, we have the warning signs and notes and what actions that we should take when these signs are present on the fire ground. So it's a really good table. Then we talk about the wind-driven fires and the effects on wind on structure and how that affects the fire. A real basic is going through the classes of fire, A, B, C, D, and Class K. And then the chapter finally ends with a real thorough review on the art of reading smoke. This is based on Dave Dodson's original presentation, and it closely mirrors the information that is in the Safety Officer book, his new book. I forget what edition it is, but anyway, we're going to talk about the art of reading smoke in here as well. The 4 factors: smoke is fuel, fuels have changed, fuels have trigger points, and occupant survivability profiles. We're going to talk about the 4 steps of reading smoke, right? We got to determine the key elements of smoke, which is volume, velocity, density, and color. We review that. Determine what's influencing those key elements. determine the rate of change, and then finally predicting the event. I think one of the most important parts of this chapter is reading the smoke through the door. There's some really good illustrations in here, as well as some photographs to talk about the flow path. For example, when you first open the front door of a structure and you have fresh air going in on the bottom and you have smoke coming out, that is a bidirectional flow path where there's an inlet and an outlet, an exhaust portal, using the same door. So those are indicative of an early incipient or a fire that's moving towards the fully developed stage, and there's still time in that. Fresh air in is a lot of times the tunnel that we use to help find the seat of the fire. A real rapid rush of smoke in is a classic indication that this is a vent-limited fire and the fire is starving for oxygen. When you open a door and it becomes a unidirectional flow path with all the air going in, no smoke coming out, then that's an indication that the fire is probably above you. Conversely, if you open up a door and the smoke all of a sudden starts billowing out and encompasses the top to the bottom, then you're at the top of the chimney. That is an exit exhaust portal of a unidirectional flow path, and indicative that the fire is in the basement or on the level below your entry point. So these are some of the things that we're talking about in Chapter 2, Fire Dynamics. We're going to talk about Chapter 4 today. Chapter 4 is my own analysis of the UL-NIST experiments. By now we're all familiar with the UL-NIST experiments, but there's still some apprehension. The fire service on a whole is understanding it better, but there's still good people on both sides of the argument and are still cautious with going forward and accepting everything that UL-NIST is saying or recommending. I think it's funny, in light of this COVID-19 coronavirus, to see how fire departments are quickly accepting this information, and they're wearing masks and they're taking all these recommended precautions because of the danger, and it's just widely accepted that you have to do this. Yet when you have something like the UL-NIST recommendations when it comes to firefighting, there's still so much resistance to accepting this type of science in the recommendations. So I thought that was kind of a funny comparison on how the fire service accepts one position and has trouble accepting another, when the bottom line is the end game is they're all trying to keep you safe. So, but that's a different commentary. So let's talk about Chapter 4. This is my own overview of the UL-NIST experiments. The conclusion, I think, is really interesting. They don't really say it, but I've made this conclusion myself. It's the first figure that I use, figure 4-1, shows a lithograph of colonial firefighting with these firefighters using the hand pump, and there's a firefighter on a nozzle and he's shooting water right through the window from the outside, like a colonial transitional attack. And we've come full circle now, because that's how they used to do it in colonial America firefighting, and that's what we're saying again: shoot water in from the outside, the transitional attack, and how effective it is in cooling temperatures and changing the interior environment as fast as possible. So I thought that was kind of interesting, a little bit of humor there. So this chapter starts out with the overview of UL-NIST and goes into fire behavior. Again, now we're starting to talk about the curves again, and it talks about the curves with ventilation limited fires. And what happens, what we're seeing is that in the past we used to think that ventilating a fire lifted and released the heat, which it does, you do get lift, but it also creates a flow path, which I don't think we fully understood. And once that flow path is created, it brings in fresh air, which naturally accelerates and intensifies the heat release rate of the fire. You get a bigger fire because there's more oxygen coming into it. And so without the immediate application of water to counteract the effects of ventilation, the fire is going to get bigger. And pretty much the first part of this chapter talks about that. We review the changing environment, the comparison between legacy fuels and modern fuels. We talk about the effects of the fires on the windows. So we're starting to talk a little bit more about the signs of windows and what's happening when you do your 360. And you need to look at the windows carefully because the windows are giving you some signs on what stage the fire is inside, right? It talks about the new stage of fire growth, which we call explosive growth stage. What happens is the fire starts in the incipient stage, and maybe you can have explosive growth, and because of the windows and the construction that holds the fire doesn't fail, the fire will run out of oxygen and then go into a ventilation limited stage. There's a lot of terms for that, and I discuss that in the book. Ventilation limited seems to be the dominant term, but it could also be referred to as an oxygen deficient atmosphere, ventilation controlled. There's different terms, but the oxygen runs out, and so the curve starts going down. Temperatures are cooling. And then when it gets a new source of oxygen, which is typically the firefighters making entry for an attack, all of a sudden you get this second phase of explosive fire growth, and that spikes the curve. So we discussed that. We talk about survivability profiles. These are first talked about by Battalion Chief Steve Marsar from the FDNY. He did his thesis paper at the National Fire Academy and first came up with the term survivability profile. But this here goes into extent on how the temperatures are relevant compared to the human threshold of unprotected skin, which is relatively very low, and talks about the toxicity of smoke. And based on these things, how really what's the likelihood that you're going to have a viable occupant that's going to make it through this fire? So we need to understand the science behind the survivability profile. It's always been a moral decision to say, well, there could be somebody in there, so we have to go in. And a lot of firefighter deaths have happened when there wasn't anybody in there. But we also now have to use the science so that we're not faced with this moral dilemma. Yes, there could be somebody in there, but based on the survivability profile, if they are, they're probably dead, or the survivability profile is negative or extremely limited. And we have to use the science to help us make a risk-benefit analysis and judgment to send firefighters inside a hostile interior. Best thing to do is get water on there and change the environment and lower the temperatures. That gives us our greatest margin for safety. So again, we start talking about flow paths again, which I talked about in the last chapter. We clearly define bidirectional and unidirectional flow path for you. You get to understand the intake and the exit portal concept and how that affects fire. We talk about the fire curtains that are used and the fire blankets that cover the flow path intake, right, where the air is coming in. If you put a barrier there, then there's no fresh air coming in. If there's no fresh air coming in, the fire doesn't have the oxygen it needs to grow or to be sustained, and temperatures drop and the fire decreases in intensity. So we talk about how those come into play. We talk a lot about shooting the water through a window or a door when you have flames visible. The term that we use is a transitional attack, offensive to defensive. It could be called hitting it hard from the yard, softening the target. These are all terms used to get fast water onto the fire, which the UL-NIST tests have shown immediately reduce temperatures and increase the survivability profile. Again, the main thing is you're trying to reset that fire and keeping it from ascending to flashover. Once flashover happens in the house or the compartment, then it's game over for that compartment. Doesn't mean there isn't a positive survivability profile in other parts of the structure or the house. There is, and we need to take offensive action towards that. But for that compartment, it's a race against flashover, both for the occupant and the firefighter, because the firefighter, if you get caught in a flashover, your chance of surviving that is very nil. Our PPE is only rated for like 575 degrees for 17 seconds. Well, what's the temperature of a flashover? It could be well over 1,000 degrees. So we talk about that. In the UL-NIST, it talks about water not pushing fire. And so that needs to be explained, because yes, it doesn't, but with straight streams, solid bore streams, yeah, you can have no disruption of the turbulence of the flows. But with a wide fog, we can push the fire per se, but the vapors by entraining the air. And we've all seen that when we've done that drill in drill school with either the propane Christmas tree or the propane tank, right? When we do those drills, which are primarily a confidence building drill, you're attacking that prop on a wide fog. As you get closer, you sort of narrow it. But if you were to go in with a straight stream, that propane fire would come right at you. So the wide fog does keep fire awake, confined, pushes away from us, if you want to use that term. So there needs to be a clarification. The text goes in depth and tells you the advantages of using the fog and the straight stream. You do need to use a fog when you want to push and entrain air to keep smoke, fumes, and I'd say even fire away from a trapped occupant or a downed firefighter. So we go into a little more explanation on the uses of straight stream and fog. And then we go back into reading windows again. We got to continue to talk about that in relation to the UL-NIST and all the things that they're talking about. The UL-NIST recommendations ends with identifying basement fires as an important subject that needs to be addressed in the fire service, because they are so dangerous and we've had so many line of duty deaths and near misses fighting basement fires. Now, basement fires are one of the most dangerous and difficult fires that we have in the fire service, but they don't have to be. If we understand the science, we can make them one of the safest type of fires, but we have to look at new ways of attacking basement fires. So the chapter 4 ends with a very thorough explanation of the fire science behind basement fires, how to read the smoke from the doors, understanding the temperatures that are present using the NIST models. When firefighters traditionally take an interior stair to go down a basement, they run the risk of encountering temperatures that are 800 to 1,000 degrees. They can't survive those temperatures. I list a couple of case studies in there where firefighters have basically gotten themselves into a chimney where the bidirectional flow path has converted into a unidirectional flow path. And that happens when either a door or a window is opened or fails on the low side, basement level, and the high side door where the firefighters made entry. So in essence, they're coming down, all of a sudden they're caught in the chimney. You have fresh air coming in from below, going right out, unidirectional, and it's blowing all the hot gases, fire and smoke right into the firefighters. In other words, the firefighters are between where the fire is and where it wants to go. You cannot survive this event. We have to understand the physics behind these situations and look at different ways of approaching basement fires. So the text is very, very thorough in discussing this, as well as the importance of using distributor nozzles. A distributor nozzle in a basement is basically like creating a sprinkler system for a basement. And that's ultimately the way we need to start looking at attacking basement fires. We need to create the same situation that is created as if that basement were sprinklered. Finally, it ends with the Parker Doctrine. The Parker Doctrine is basically a statement that says that an organization will resist change and tradition, a change to tradition and current practices, because it's something new. And it's not until the pain of staying the course becomes greater than implementing the change, then that change will happen. Otherwise, there's going to be resistance. And that's kind of where we're at right now. So my job is to try and educate you so that you can make that transition and accept the new science, which makes sense, and apply it to your strategy and tactics. Thanks for checking this out. Today we're going to talk about Chapter 8, Initial Size Up and Developing a Quick Incident Action Plan. Size Up is really important. In the third edition, Size Up was only 2 paragraphs. It took up like half a column of a page, and it was just defined. Yet, a lack of a complete size up or a size up including a 360-degree walk around is quite frequently one of the top 5 factors that are attributed to a line of duty death on the fire ground. So, again, if that keeps popping up in the top 5, we have to look at the curriculum and say, how are we teaching size up? And I don't think we are. I think we're just defining it and not teaching it. So Chapter 8 is really trying to teach you how to do a complete size up. This is going to be a very provocative chapter. It's going to certainly stir up a lot of discussion in the fire service. I'm introducing some new concepts here that I haven't seen in any other strategy and tactics textbook. So we start with the traditional definition of size up, and there's a complete bulleted list, but we're adding the risk management factor in there, the risk-benefit analysis. The whole fire service is driven by risk management. And so we say it and we define it, but how do we apply it when we're on the fire ground? So this chapter talks about doing that and incorporating it into the size up. We have a very detailed bulleted list that covers just about everything you can think of that needs to be evaluated, as well as some risk priority, high frequency and low frequency, high risk, low risk events. There's a matrix here that's really good. So we talk a lot about risk management. How do you manage risk and prioritize your risk? We talk about the 3 phases of size up. There's a sample of a pre-incident plan, and you can use it as a template to fine-tune yours or substitute it. It's very complete, or it might be too much information for you. But we talk about the 3 phases of size up, the pre-incident size up, and then we go into the initial size up, step 2, right? Phase 2, initial size up. And so we talk about setting up the fire ground with a complete size up. I'm introducing a new acronym here to help identify basements. The lack of identifying a basement is a problem and has led to firefighter injuries, close calls, and line of duty deaths. Either a basement wasn't known to exist, caught them by surprise, or they weren't aware that the fire was in the basement. So I address that issue to help you identify basements in this chapter. We do talk about the traditional size up acronyms that are used, like coal was well, slicers, Wallace was hot, slab savers. So we do talk about those. Those all have to be included at some point, but they're very hard to remember. And so I'm taking a new approach by learning how to do a size up and identify your problems. For example, life safety is always the first incident priority along with rescue. But even if you show up and you see a lady at a window with flames and smoke visible, but the complex is barricaded by an electric gate, you can't do rescue. You can't throw a ladder, lay any hose lines. Your first problem is access. And so you're going to solve that with forcible entry. So this is going to teach you to identify and prioritize your problems that confront you and exist before going to any of the life safety or rescue acronyms. So I'm going to teach you how to identify your problems, come up with a strategy and a tactic, and how many resources it's going to take to accomplish that. The other issue that often gets accredited in the top 5 is the lack of a functional accountability system. We use dog tags, we have rosters, but there isn't anything in any books that I've seen that teaches you how to actually perform firefighter accountability. Again, we only define it. This chapter is going to teach you how easy it is to keep track of firefighters on the fire ground. The key is you have to make you have to be able to account for those firefighters when you're making the tactical assignments to those crews. So I'm going to teach you how to do that. And then the chapter ends with 4 exercises on how to find firefighters who call maydays using the accountability system, okay? So chapter 8 is going to teach you everything you need to do a complete size up, identify your problems, come up with a strategy, tactics, and how many resources it's going to take to accomplish that. And I'm going to teach you how to run a basic fire with your first alarm assignment so that you make all your assignments with firefighter accountability. That's what chapter 8 is all about. I think you'll like it. Thanks for checking it out. Today we're going to talk about chapter 15. Chapter 15 is on high-rise firefighting. As you notice in most cities, they're not making any more real estate. Everything's going up. Buildings that were there for years that were 1 or 2 stories, they're being knocked down and they're being replaced with multi-story buildings, either low-rise or just under 7 stories, maybe up to 6. So they stay. They're not technically high-rise buildings and fall under the fire code to address high-rise buildings. But nevertheless, if you get a fire in a building that's even 6 stories, you're going to be doing standpipe operations, and pretty much the whole evolution is going to be played out the same way on floor 6 as it would be on floor 16 or 26. So that's what this chapter is all about. I want to write it from the perspective that it's not just for major metropolitan cities. Even small departments have to learn how to fight high-rise fires or low-rise and mid-rise buildings with standpipes. Interesting to note that most high-rise fires start on the 12th story or less. Many of them start in the basement, lower level, floor 1 and 2. A good example is the MGM Grand Hotel fire. That started in the casino. So it's very plausible that any city can have a, quote, high-rise fire, and that's what this is all about. We talk about building construction, center core, side core, things like that, and then we pretty much just go in a sequence. We start with why you need to pre-fire high-rise buildings. That's the secret to success. It's not shooting from the hip once you arrive. You have to have your plan in place. We talk about size up from the time of the alarm, what the company officer and the driver are looking for en route. We talk about taking which standpipe you're going to take. We talk about combination standpipes and sprinkler system connections, all those things. We go into lobby control, elevator control, setting up the staging 2 floors below the fire, the challenges and some of the curveballs that are thrown with water supply and hooking up, hooking up hose lines in the stairwell, and then making the fire attack. What size hose do we use, the type of nozzles? It makes a difference on whether the high-rise is a residential high-rise or an open floor plan commercial high-rise. So these things are all talked about in there. We talk about the different systems that come into play, like the HVAC system. I mentioned the elevators, the fire pump. These things are all mentioned in this chapter. And then we talk about the attack. Considerable amount of time is spent on the different stairwells, the fire attack stairwell and the evacuation stairwell, because people are going to be all over this building, and you need to be able to control where the occupants are, where they're going, sometimes even before you make the attack. Because once you start down that hallway and you end up charging that stairwell, there could be people trapped, and there have been people trapped, and it just adds to the problem because your actions could directly lead to a civilian fatality. Oftentimes ventilation has to wait until the fire is knocked down but the chapter ends with how do you ventilate a high-rise fire. And so I talk about a strategy and a tactic called transitional ventilation. And it's just channeling floor by floor where you're going to direct the smoke. It's not a difficult concept, but I think I've done a pretty good job at explaining it. Definitely going to take some practice for any department to ventilate a high-rise building. But anyway, transitional ventilation is in here, new concept. Finally, I do use the case studies of the First Interstate, the One Meridian Plaza, the MGM fire, and a couple of other fires that recently happened in the area, one in San Francisco and one in Los Angeles. I think it's important that these fires illustrate what can and probably will happen in a high-rise fire. Their after-action reports are not just for their department. We should take that information and apply it to standard practices for strategy and tactics in fighting fires in high-rise buildings, and that's what I attempted to do in this chapter. So I hope you like it. Thanks for checking it out.